Okay, so in this part, we're going to finish off question 15 until the very end of your tutorial sheet 8. So this is an implicity case. They are saying, find 2 points where the curve intersects the x-axis. Show that the tangents to the curves at these points are parallel. So we need to find 2 points where the curve intersects the x-axis. So if you have x squared plus, this is number 15, xy plus y squared is equal to 7. So where we're intersecting the x-axis, y is equal to 0, meaning wherever there's y, put a 0. This is going to give us x is equal to 7. We find the square root, because this will be a 0, that will be 0 because of this, the x-axis. That's the reason why we're having that, meaning x is equal to plus or minus the root of 7, meaning we have root 7 comma 0, and we have root 7 comma 0. Yeah, so these are the 2 points that we need to find, point A and point B. That is the first part here. Now we need to show that the tangents to these curves are parallel. So they are parallel only if their gradients are supposed to be the same. So we differentiate. This is going to be, we differentiate x, that becomes 2x. We differentiate this using product rule, that's going to be x, y, that's 1. This is dy dx, because the derivative of x is 1, right? Then we have this times that. That will give us x dy dx, then plus y, plus a 2y dy dx. Equate this to 0. And in this equation, we're going to plug in negative root 7 wherever there's x, and wherever there's y we put 0. So let's check this point first. We'll have 2 negative 7 root 7. We have plus, this is negative root 7. I'll call this m1. This is a 0, that's going to be a 0, is equal to that. So it's 2 root 7 minus root 7 is m1 is equal to 0. This is just going to be root 7 m1 is equal to 2 root 7. Root 7 negative root 7, meaning m1 is just equal to negative 2. That's what we get. The next thing is, at this point, we try to get the slope at this point. Let me do it in a different color. So if we replace 2 root 7, this is root 7 dy dx, that's our m2. This is a 0, that's a 0. Equate this to that. You will notice that if this is m2, negative 2 root 7, you will notice that if we square root here, meaning m2 is equal to what? This. So you have the same slope. That's the reason why we're saying these guys are parallel, because they have the same gradient. Yeah, so we're saying show, right? We've shown that they have the same slope. Any 2 lines that are parallel to each other have the same slope. Then here they're saying find any points where the tangent to the curve is parallel to the x-axis. And then they're saying find any point where the tangent to the curve is parallel to the y-axis. Okay, so they're saying find any points where the tangent, so we can get the tangent. So we have 2 tangents, right? So we'll just pick one of them because they have the same behavior. So take the tangent that has y, that has this negative 2. I'll pick the point root of 7 comma 0. So the tangent to this is y minus 0. Negative, this is negative 2 root 7. This gives us y, 2x. This is positive. This is what we get. So this is the line of this is the equation of the tangent. Whenever you are discussing anything to do with the line parallel to x-axis is here. X-axis. let's say if there's a line parallel to that, let's say y is equal to 1, for instance. They said n, right? So if y is equal to this, meaning we're going to equate where there's y, we put what? We put because they want the equation, right? They're saying find any points where this is parallel to this. So we just take this and equate 1 to be equal to negative 2x plus 2 root 7. This is going to give us 1 minus 2 root 7. This is negative 2x divided by that. Yeah, so x is equal to this guy, 1 minus 2 root 7 over negative 2 comma the 1 that we picked. Yeah, so any point, provided the line you are sketching is parallel to the x-axis. Yeah, the same applies when you say the y-axis, x is equal to something. Let's say x is equal to, let's say negative 1, meaning you have to equate, by x we put negative 1. This would have been y, so negative 1. Where there's x, put a negative 1. That's going to be 2 plus 2 root 7. So this answers the second part of the question. This answers the first part. So these are the type of questions that are just going to be needed mostly under integration. For now, this is not expected to be in your test 2. It's okay for this part to be a little bit confusing. Question 6 is a must. 16 is a must. These are the basic applications of differentiation. So yeah, you have to know this. So I'll just solve one because of time, and these are the questions being a lot. I'll just solve one of these guys so that you get the concept. I'll solve the first one. We need to find the derivative, indicate the points where the function is increasing, and also places where the function is decreasing. So we have, this is y, this is question 16. Y is equal to x squared minus 5x plus 6. We differentiate. This gives us 2x minus 5. To find, this is a derivative. To find where it's decreasing, we need to solve 2x minus 5. Decreasing means less than 0. This will just give us 2x less than 5 divided by this. X is decreasing in this part. Then to find where it's increasing, we have 2x minus 5. This is greater than 0. This is 2x greater than 5 divided by that. X is greater than 5 over 2. So this is the interval where it's increasing. That's the interval where it's decreasing. This is how we check. Just differentiate, get the first derivative, do less than 0, you find where it's decreasing. In an event where you had a polynomial, like this case here, number, I think let me do the last one there, where it's a polynomial already, right? Now if you differentiate it, that's going to give you another polynomial. That's f of x is equal to x squared, x to the power 4 I mean, so that's x to the power 4 here, x to the power 4 minus 4x to the power 3. So we differentiate, so the derivative is just going to be 4x to the power 3 minus a 12x squared. Then we say to find where it's decreasing, we say 4x3 minus 12x squared should be less than 0. So meaning we're trying to solve this. You're going to change 4x3 minus 12x squared, put an equal sign, factorize this guy and a 4, meaning you're remaining with x minus a 3 is equal to 0. So it will be this guy equal to 0 gives you x is equal to 0. This guy will give you x is equal to a 3. We need to test where is the function going to be decreasing or increasing. We just check, pick any number that's less than 0, because we are checking what these two guys, these two, 4x squared and x minus 3. So pick negative 1 for instance. That's going to give us a positive. That's a negative. The whole outcome is negative. Pick a 2. That's positive. That's negative. This is negative. Pick a 4. That's going to be positive. That's going to be positive. Yeah, so it's decreasing below 3. You're seeing where it's negative. That's why it's decreasing. So negative infinity up to the 3. Then it's increasing from 3 up to positive infinity, where it's positive, right? So this is how we handle question number 16. That's what we do for the rest of the questions. Look at number 17. In the following, find the coordinates of the stationary points, the maximum, the minimum, the inflation. Then we should be able to sketch. So as well, I'll just do question 1 here. You get the idea of stationary points. So the first question here says, okay, so this is what you have. Then the first thing is to differentiate it. So get the dy dx. So the dy dx is going to be a 6x squared plus 6x minus 72. Then once you get the derivative, like the way we've done here, solve this, equate it to 0, and solve x squared plus 6x minus 72 is equal to that. This is x squared plus x minus, this is going to be a 12. We're dividing everything by a 6, right? So that we reduce it. Here we're going to solve this. 4x minus 3x minus 12. This will be x plus 4 minus 3x plus 4 is equal to 0. Then we have x minus 3. Then we have x plus 4. X is equal to 3 and x is equal to negative 4. Yeah, so if we have these two values, we're going to let them be here. We have 3, we have x is equal to negative 4. You put them in the original question to get the corresponding y values. So we plug these guys in the original question. I won't do that here because of time. In this original question, this guy, where there's x, plug the 3. Where there's x, again, plug the negative 4. So I'll just show it as f of 3. And I'll also show it here as f of negative 4. That's the values that are supposed to be there. Then we differentiate the equation. So these are the stationary points. Stationary points, what we've gotten here, these are the stationary points. So we'll call this one A. We'll call this one here to be B. Then you're going to differentiate this again for the second time. And when you do so, you're going to get the derivative to be as follows. That's 12x then plus 6, right? So this is the second derivative. That's 12x then plus 6. So you plug in the numbers, the values of x you have. If you plug in 3, so at the point 3 comma f of 3, if you plug in 3 there, it gives you 12. This is a 3 plus this. So this is just by 3, then plus a 6. It's giving me a 42. So the answer we're getting is greater than 0, meaning this point, this stationary point, was a minimum. Then for the other guy, if we plug in negative what? We plug in negative 4. This is plus 6. It's supposed to be less than 0, right? So this other point is a maximum. So this is a maximum because the second derivative is less than 0. Then this one here is going to be a minimum. Now this should be able to help you to sketch. So under calculus, when we're sketching, we're just interested in these same 2 points. We have 3. So 3 comma f of 3 somewhere there is a minimum. Then we have negative 4 somewhere there. So this is supposed to be a maximum. Yeah, so the question has to be, according to this, the constant is 5, right? So we're having a 5. So we need to have something that looks like this. It passes there. Passes at 5. Comes and passes there and then goes up, something like that. This should be the turning point. This is the minimum, 3 comma, the 3 comma f of 3. Then this is simply a negative f, a negative 4 and f of negative 4. So something like this. Yeah, so in sketching calculus, you can proceed to just factorize this like we did under polynomials. Try to completely factorize this to find out where we might be touching the x-axis, but it's not relevant here. So no wonder we're just using the minimum and the maximum, the stationary points are enough to sketch. So this is what you are supposed to do on question number 17. Yeah, so look at number 18. So number 18, we did it in class. We said for you to find the initial velocity and initial acceleration, you just have to differentiate this equation, because that's s of t So if we expand this equation, we're going to get t squared minus 3t, and this is 8t minus 9. This is going to be 8t to the power 3. That's going to be a negative 9t squared. Then this is minus 24t squared. This is plus a 27t. This is just 8t to the power 3. Minus, that's going to be, what is it, a 33t squared plus a 27t. So this is the displacement equation. When you differentiate the displacement equation, you get the velocity equation. So this is going to give us a 24t squared minus 66t. Then you have plus 27. So when t is equal to 0, this gives you 0, 0. So the initial velocity is actually 27 meters per second. Then when you differentiate the equation for velocity, you get the one for acceleration, because the change in velocity means it's acceleration. This will be a 48t minus 66. When t is equal to 0, the acceleration here would have been negative 66 meters per second squared. So that answers the first question, this guy here. This equation, when differentiated, gives you the velocity equation. Differentiate again, what you get is acceleration. Yeah, so they wanted the initial meaning before any time is covered, meaning t is equal to 0. The second one, they're saying find the velocity and the acceleration at the time when time was 3 seconds. So just plug in 3 seconds. 3 in this equation. So to get the velocity, you plug your 3 here, you get the velocity. Plug your 3 there, you get the acceleration at t is equal to 3 seconds. Yeah, the next thing is saying find the values of t for which the object can change or changes direction. We solve this to be t is equal to 0. This one here to be t is equal to 3. We solve this other piece, it will be t is equal to 9/8. So these are the 3 pieces that we need. Yeah, the number 4, they're saying find for what value of t the object's velocity is minimum. So we got the velocity expression, right? We just have to complete the square of this. Once you complete the square to give you the turning point, the turning point is simply the minimum. Yeah, and the minimum will give you, so here, since I just want to go direct, the turning point, the formula is this. And the other guy that you have here, I'm interested in this because that's the time. So we can just say, according to this quadratic, our b is -6. There's a negative outside, then there is 2a, which is 24. So this is the same as 33/24 seconds. That's the time that gives you the minimum. So you're just completing the square of the second derivative, which is our velocity equation. Complete the square, get the turning point. That turning point is our minimum. That's what they're implying. And when you get the first coordinate of that minimum, it's going to be the time, which is simply the time it takes for us to achieve that minimum. That's the t, what we've gotten. Yeah, so look at number 19. They're saying the delivery cost per ton of bananas when d tons of bananas is shipped. So that's what you have. Find the value of x for which the delivery cost per ton of bananas is minimum. Then find the value of the minimum delivery cost. Explain why this cost is minimum rather than maximum. So here we're having d. That's number 19. We have d. So it's d is equal to 3x. Yeah, So this is just a distraction. It's just like the domain of this cap is here to say all numbers greater than, all numbers greater than 0. So if this is what we have, we can first of all get this in something we're familiar with. 10x to the power negative this, differentiate it. So d prime is going to be 3 plus this is going to be negative 10 x to the power negative 2. So we solve this guy, we equate it to 0. 3 negative 10 x to the power negative 10 negative 2 is equal to 0, because we only have 1 point here. The negatives can cancel. We take the 3 on the other side. This is just going to be x minus this is equal to 3 over 10. Then here we can just introduce 1 over negative 2, 1 over negative 2. So x is equal to this. So the x value is the one that helps us to get the d value. So we get this x and replace it in the original, we get the amount that was needed. So this here is a minimum, because if you differentiate this again, the answer is going to be negative. Yeah, so here when they say, is it going to be, find the value of x. We've gotten it. X is equal to what? Is it 3 over 10? 3 over 10, negative half. They're saying find the value for the mean. So meaning we replace this guy in the original, like I was saying, we need to get the cost at this minimum. This x value is the minimum. Yeah, so we can just, okay, so the value of x we've gotten is according to this, right? So this is how we get it here. So we've gotten the value to be x is equal to, there's a 3 over 10 to the power negative half, right? So replace it in the original equation, which said this, is it 10 this, replace it here to get the value of the cost. This is going to be 10. And this here is going to be, I assume this is going to be the same as t. Okay, it's the same thing because the sign won't change this guy, so it's okay. Yeah, even if we say it's a 3 over 10, still the same. 10. So this here will be affected by negative. Yeah, so this is going to be, it was negative half, so it will be positive now. It's going to be half, so we have this. Yeah, so this is the cost in kwacha. Yeah, so that's what you get. Then your number 20, so pay attention, number 20. Explain this is minimum. It's a minimum because the second derivative, so you can just say d prime is greater than 0 at x is equal to 3. This is the power negative, this is to the power negative half, right? Yes. Then look at number 20. Number 20 is a type of question that they can ask you. Yeah, so number 20 here, they're saying a rectangular garden is fenced on 3 sides and the house forms the 4th side. So meaning, you know how we make up a rectangle, right? So we've only used this portion and this portion. So you can call this y, call this y, call this x. The total perimeter was 80, meaning y plus x is equal to 80, meaning x is equal to 80 minus 2y. And the area of a rectangle is x, y in this case, LB, right? So xy. Wherever there's x, we can make a substitution with 80 minus 2y. So this is going to be 80 minus 2y. Then we have y. A is equal to 80y minus 2y squared. This is going to give us a is equal to negative 2y squared plus 80y. Then this is going to simply give us, you complete the square here. This is, this has been the answer to the first question. We've gotten it, right? We've derived it because they're saying Given that the total length of the fence is 80, show that the area of the garden is equal to this. We've done that. Then the last one says, given that the area is a maximum for this fence, find the dimensions of the enclosed garden, the x and the y value, and then the area enclosed. So according to what we are doing, we're here. We're trying to put this in a quadratic form and completing its square. So when you complete the square here, is going to be 40, negative 2. This is y minus, that's a 20, squared minus 20, that's going to give us 400. Multiply back by this, that's negative 2, y minus 20 squared plus, that's 800. So this is a completed square form, meaning y minus 20 is equal to 0, meaning y is equal to what? Y is equal to 20. So if y is equal to 20, remember we said x is equal to 80 minus 2y. So meaning 80 minus 220, that's just a 40. So x is equal to 40 and y is equal to 20, meaning the total area is 800 because it's xy, right? This times that. Yeah. That's what we get. And it's area, so you need to write it as units squared. We just don't know the units, but it's area, right? Yeah. So that's what we were supposed to do on question 20. Please be on the lookout of this one. These are the type of questions they can ask. Then the next one is going to be, they're saying what? Find the coordinates of the points of a zero gradient on the curve with implicity. So zero gradient means the whole derivative is going to be equal to 0. We differentiate it. So first of all, we have to differentiate this, right? We're going to use implicity. We said implicity, we differentiate everything normally, but whenever you differentiate y, you put a dy dx to the answer that you've gotten. So here, this is what we're going to get. That's a 0. Let's go to that. So we make this to be the subject because we need they're saying this is a 0. Look at what they said here. So this is interesting. Find the coordinates of the points of zero gradient on the curve with implicit equation, meaning after we differentiate it, like the way we're having here, the dy dx, which is the slope, right, is supposed to be 0 at these particular points that have not been given to us. So dy dx, those are the gradients. These guys are supposed to be what? 0. So this part will be 0, this part will be 0. We'll have 2x minus this is equal to 0, meaning 2x is equal to 6. Then meaning x is equal to what? A 3. Once you get x to be equal to 3, plug it in there. So you have 3 already. You need to find the value of y, right? So 3 there, that's a 9. We're looking for y. This is what? Minus 18, right? Minus 16y. Then we are having what? We are having, let me do it on a different page. So we are having, let me use a different color. So, okay, yeah. We're putting a 3 there. That's going to be a 9 plus 4y. That's 18 minus 16y plus a 21 is equal to 0. It's the same as 4y squared minus 16y. So we're having a 9, that's negative that's 21 minus 9. So we're getting a 12. So this here is just supposed to be a 12. Divide everything by 4. You're going to get y squared minus 4y. Then that's a 3 is equal to 0, by the way. So you have y squared minus 3y minus y plus a 3 is equal to 0. That's y minus 3 minus 1, y minus 3 is equal to 0. Y is equal to 3 and y is equal to 1. So the point we want is 3, 3 or 3, 1. These are the 2 points where the gradient can be 0. That's the answer to your question number 21. So this is something interesting. Please listen to what I've done. Try to replay it. Do it first. Replay it. Number 22, they're saying a curve has this equation. Find the exact value of the dy dx at the point 2, negative 3. We're just going to differentiate this. When you differentiate it, wherever there's x, put 2. Wherever there's y, put a negative 3. That's what we need. So we have, this is question 21. 3 power x is equal to, this is what? This is y minus 2xy, is it? If I'm not mistaken. Yeah, that's what we are getting. So we differentiate this, is going to be 3x ln 3. This is equal to dy dx. This is going to be 2 waiting for x dy dx. By now you should know. I want to explain how I'm getting this. That's going to be a y this side. So wherever there is x, put your what? Put your 2. Wherever there's y, put negative 3. That's a point, right? Yeah. So put a 2 there. That's going to be 3 to the power 2. Then ln 3 is equal to, we're looking for the slope. 2. Put a 3 there. Put a 2. Put a 2. We say 2m. That's the slope. Then where there's this, put a negative 3. So this will just be a 9 ln 3 is equal to m1 minus a 4 m2 plus a 6. So we have 9 ln 3 minus a 6 is equal to negative 3. This is the same thing. This is negative. Divide by this, then divide by that. Yeah, so the answer should be, the gradient is the same as, just leave it the way it is without even simplify, but you can simplify it because 3 can divide everything, right? That's the exact value of the slope. 3, then ln 3 minus a 2, down there is a negative 1, which is the same as the negative, that's going to be the same as 2 minus 3, then ln 3. So that's the slope. That's how we do question number 22. Then look at number 23. Find the gradient of the curve. Again, we do the same, just different. Forget about these. These are just like domains. So we differentiate what we have. Then we plug in where there's x, put this guy. And you can first of all plug in the 4 there to get the value of y, right? So ln y squared is equal to half, put a 4. We need to get a point. We just have 4. We don't know the y value. Not I'm putting 4 wherever there is x. Then there is ln, there is 4 minus 1. So ln y squared will be, this is a 2, ln 3. This is going to be ln y squared is equal to ln 9. When the 2 goes back, the ln can cancel, meaning y squared is equal to 9 square root. So y is equal to 3. That's the 3. We need this full point because when we differentiate, the derivative here is going to be 2y, then dy dx over the y squared is equal to, we're differentiating these using product rule, so we are supposed to have half x and the ln of x minus 1. This is just half. This one here will be 1 over x minus 1. So we're going to get half of x and 1 x minus 1 plus, that's half ln of x minus 1. Yeah, so now wherever there is x, put the what? Put the 4, right? Put the 4. This is going to be half of 4. You have 1 over 4 minus 1 plus half ln, say 4 minus 1. This side you have 2, 3 dy dx over, we have 3 squared. So for dy dx here, if you're done solving it, so 1, 3, 1, 3 can cancel. You have 2 over 3 m. I'll just call it m. That's the slope, dy dx. This here is a 2. That's going to be 2 over 3 plus, this is going to be ln 3. So we can just divide here by 2 over 3, divide this side by 2 over 3. Yeah? So we're going to have m1 is just 2 over 3 plus 1 over 2 ln 3, everything over 2 over 3. That's what you get. That's the slope. I hope you get the idea here. Then look at the last one. The last one is also very easy. They just want us to, they're saying we have sine x and cos y is equal to half, right? Find the expression for the dy dx. So we are having sine x cos y is equal to half. Differentiate this part, you get cos x. Differentiate this, you get negative sine y with a dy dx is equal to what? A 0. Then they're asking us for what? Also, it satisfies this equation. That's what they're giving us, where x is something that comes from here. Find an expression for this. Okay, we do have an expression. Then they're saying for dy dx, an expression for dy dx, negative sine dy dx is equal to negative cos x divided with negative sine y, meaning dy dx, the expression is just cos x over sine y. Yeah, so please don't mix the letters. This here there's x and y, so it's actually implicity. That's what we get. Then now the last question is saying find the coordinates of the stationary points. The stationary points coordinate are when the first derivative is equal to 0, right? So we're going to say cos x then sine y is equal to 0. Cross multiply, this just gives us cos x is equal to 0, meaning x is equal to cos inverse of what? Of 0 degrees, which is just on the graph of cos. The only thing that gives us 0 is 90 and 270. So we're going to go with so x is equal to a 90 and 270, which is 3 pi over 2. Yeah, so they're saying the coordinates, right? Once you get this, okay, there's a 90, then there is a 270 comma something, right? Replace these are the x values. These are x values because this is x. Replace them in the original equation to get the corresponding y values, because we said wherever you have cos y and sine x added, they gave us a 0.5. So you are going to replace x is 90. So sine 90 is what? Sine 90 plus cos y is equal to half. So sine 90 is a 1, right? 1 goes on the other side to give us negative half. Cos inverse of half, we're going to take cos inverse is what? 60. Now we're going to consider the place where 60 or cos is negative, which is this and that. And remember y had an interval. Y only ranges from negative 180 to 80. Yeah, so the answer we'll pick is just this. The same applies this side. Oh no, there's no this side because x also falls in the same interval, right? X also was only in negative 180 to 180, so the other stationary point won't be considered because it's out of the range. So the only thing we have is this. Yeah, that would be your stationary points. The other guy is invalid. So feel free guys to ask questions on WhatsApp. This brings us to the end of tutorial sheet 8. So this has part 1, part 2, and then this was the last part 3. Yeah, thank you so much for watching.